All right, so inverse function problem type 2. I like to switch my x and my y right away at the beginning. For some reason on this one, the Alex explanation solves it for x and then switches the x and the y at the end. Either way works. But I would say, okay, y equals negative 4x plus 9 over 7 plus 3x. So for my inverse function, x is going to equal negative 4y plus 9 over 7 plus 3y. Change your y to x and your x's to y's. Then I have to go ahead and solve that for y. So first of all, I have to get rid of my fraction. So I'm going to multiply by 7 plus 3y. So I'm going to get 7x plus 3xy equals negative 4y plus 9. I multiply there by my denominator. Since I want to solve it for y, I want my y's on one side. I'm going to move them to the left. Anything without a y on the other side. So I'm going to leave the 3xy. I'm going to add the 4y to move it over. I'm going to leave the 9 and I'm going to subtract the 7x to move that over. So anything with a y on one side, anything without a y on the other side, so that I can go ahead and factor the y out of those two terms. So y times 3x plus 4 equals 9 minus 7x. So just taking the y out of each of those. And then to solve it for y, all I have to do is divide. So my inverse function is equal to 9 minus 7x over 3x plus 4. That's only part of my problem because that's the first part, find the inverse of f. Then give the domain and the range. The domain. The domain, the bottom of my fraction can't equal 0. So 3x plus 4 can't equal 0. I'm going to minus my 4 and divide by my 3. If you really need to do it in 2 steps, go ahead, but I think you're good enough, you don't really need to. In interval notation, so in interval notation, this is one of those where this is the hole in the middle, so we go from negative infinity to negative 4/3, not including that number, and then we go from negative 4/3, again not including that number, to positive infinity. There's my domain. The range of my inverse function happens to be the domain of my original function. So on the range, I'm using the denominator of the original function. What am I doing? Not x. I'm doing 7 plus 3x cannot equal 0. I was going to solve it already. So x cannot equal negative 7/3 then, right? Subtract my 7 and divide by my 3. So for my range, it's going to look like my domain, only I'm just going to change this number. I'm lazy. I highlight it, copy and paste. So my range is going from negative infinity to negative 7/3, and then from negative 7/3 to positive infinity. So all of those things will go in for your answers. Number 11 then, same kind of thing. Here's my function in regular notation. I'm going to replace the functional notation with a y, and then I'm going to do the inverse. So the inverse would be what? x equals negative 2y over negative 8 plus y. Solving that for y, getting rid of our fraction, we're going to multiply by our negative 8 plus y, and then we would have what? Equals our negative 2y, right? I want my y's on one side, my x's on the other, so I would go ahead and move my y's to the left and my other things to the right, or whichever order you really wanted to move them. I just don't like all those negatives. So xy plus 2y would equal 8x, right? If you had all negatives on there, it'd be the same thing. Factoring my y out, y times x plus 2 equals 8x. And then, of course, I can divide. So my inverse function is equal to 8x over x plus 2. So the domain of my inverse function is negative 2. I can't have a negative 2. So I'm going to go from negative infinity to negative 2, and then from negative 2 to positive infinity, right? The x plus 2 can't equal 0, so I can't have negative 2. The range of my inverse function, which is the domain of my original function, would be 8, right? Negative 8 plus x can't equal 0, so it's a positive 8 that we can't have. So negative infinity to 8, and 8 to positive infinity. So you're using that when you find your range. And number 12, then. If I replace my f of x with the y and do the inverse, I would have what? X equals negative 4y plus 9 over 9y minus 8. Next step, we'll get rid of our fraction. And we would have equals our negative 4y plus 9, right? Moving our y's to the left and our other stuff to the right, we would then have what? 8x plus 9. That would become a positive 8x when we move it over. Factoring out our y. Y times 9x plus 4 equals 8x plus 9, and then dividing. So our inverse function is 8x plus 9 over 9x plus 4. The domain of your inverse function would be negative 4 ninths is what I can't have. So negative infinity to negative 4 ninths, and then negative 4 ninths to positive infinity. The range of my inverse function would be 8 ninths. positive 8/9, using the denominator of our original function. So negative infinity to 8/9, and then 8/9 to positive infinity. So kind of long ones.